Hi, this is lesson 322, connecting slope ratios to specific angles. This is a continuation of the last lesson where we began discussing slope triangles. And so if you haven't had a chance to watch that video, definitely I recommend watching it just so you can understand a little bit of where this information is coming from. And so I've kind of summarized this so that you can kind of see it all in one place. So the last time we saw this, they were on different graphs, and so maybe you couldn't compare them a little bit as easily as now. But the main difference between all our slope triangles that we were looking at was their slope angle, right? The difference in their slope angle and how that affected their slope ratio, right? The rise and the run of all these, right? So you'll notice as the angle increases, so does the ratio. It also increases, all right? So that's kind of, and you'll notice that every slope angle has a different slope ratio. So we're going to use this information in the problems we're going to be doing in this lesson. So for example, if we're given this triangle, the first thing I would probably look at is how does this triangle relate to all the others that we've seen? And so I'll kind of leave that on the screen so we could compare them. So the ones from the ones above, this one below, how does it compare or relate to any of the four that we've seen before? And so hopefully you notice this. It's like, well, the first thing that stands out is this 11 degrees. Like, oh, we've seen a triangle with 11 degrees. And so the nice part is, like we saw on the slope triangles, all the slope triangles that come from that same line are similar. So if we have similar triangles, that means we could use proportions. And so that's what we're going to use to solve this problem. And so normally, if I have a missing side and a triangle, I would try to use Pythagorean theorem if I have two side measurements, which I don't. I only have one side. But the fact that I have this angle definitely helps me use a different strategy. Okay, so I'm going to set up a proportion, and I'll set it up on this side. And a proportion, again, is just two fractions equal to each other. And the first fraction is going to be, well, what's the slope ratio of all the other triangles with 11 degrees? Well, that's where we look here, and the 11, so this measurement's coming from here. So I'm just going to copy this fraction because this should work for all 11 degrees slope triangles. So this is going to be 1 over 5. And then the second fraction, that's going to come from this triangle. So I want to know the rise and the run. So in this case, we're looking at y, and we're looking at 20. So I'm just going to put y over 20, and then that is pretty much most of the work. The hard part is just setting it up, but you'll notice all I did was I copied this fraction from our list, and the second fraction I just got from the rise and the run. And so rise, don't forget that always goes on top. So now we just have to solve this. We could cross multiply. We could work our magic there. So 5 times y and 1 times 20. And so that's going to give us, we'll start with 5y is equal to 20. And then we would solve this by dividing both sides by 5, which then leaves us with y equals to 4. All right, so there we figured out the missing side. So this is the basic strategy we're going to use for future problems that are just like this. And so this problem 79 from our chapter 3 gives us 6 problems to try to do the same thing with. Can you find the missing side length or angle measurements? So some of these are going to be a little bit challenging. And so I'm going to go through these, but I left these blank because for those of you that want to challenge yourself and try to do these first before I do them, I would recommend pausing the video and trying to see if you're going to do these correctly or not. So I definitely would recommend that. In the end, you'll get to see the answers and correct your work, but I definitely would recommend trying these on your own. All right, so I'm going to start going over these one by one. So definitely pause it if you're not ready for the answers. All right, so I'm going to focus on one at a time, and I'm going to zoom in to the first one a little bit. And so I'm going to set up a proportion. I know I'm going to solve these pretty much all close to the same way. And so that means I'm going to set up a proportion, and I'm going to set up some fractions for both of these. So the first fraction is going to be, and you could flip them. It doesn't really matter which is on the left or right, but I'm going to try to be consistent. And the left one is going to be what's the slope ratio for all triangles that, in this case, not 11 degrees, but I notice it's a 22 degrees. So where do I get that information? Well, I wouldn't expect you to have this memorized, but I would expect you to look back at your notes and say, okay, 22 degrees, what was it? Oh, here it is. And 22 degrees is going to be a slope ratio of 2/5. Right? So all I'm doing is copying that information. So I'm going to put 2/5. And then the second fraction is going to be the rise and run of this triangle. So in this case, this is going to be y/25. All right, so if I solve this, let me move this to the side. If we cross multiply like we normally do, then we're going to end up with 5y is equal to 50. And then if we divide both sides by 5, we will end up with y equals to 10. All right, and that's it. All right, so normally I would show the work underneath, but there's not enough room here, so I'm just going to leave it like that for now. So definitely, I would probably recommend. Oops, so let me. So definitely, your work should be something similar to this. I probably would even show a little bit more steps of dividing as well. So keep that in mind. So divide by 5, divide by 5. All right, so that would be an example of showing your work for this problem. All right, so part B, you'll notice very similar. Kind of looks like the 11-degree triangle that we saw before, but there's a slight difference on this in case you don't notice it. So in this one, we have, well, it's 11 degrees, so I'm starting to remember these. This was 1/5. But what's the rise and run of this triangle? So don't make the mistake of assuming the letter's always on top. So rise, in this case, is 100. So that's going to go on top this time. And the run is x. We don't know what that is. So I'm going to put an x at the bottom. All right, same process, cross multiply, and we end up with, so I'm going to highlight those for you, and that's going to be x times 1 is going to give us x, and 5 times 100 is going to give us 500. Well, that was an easy one. There wasn't really a lot. It's nice when you multiply by 1, so that gives you your answer right away. All right. And then C, same idea. We notice there's a 45-degree angle here. That was on our list as well. So when we set up our proportion, 45 degrees, I think I remember this one. This is 1/1. And in this triangle, rise is 13, and the run is going to be A. So this is going to be A. And then when we cross multiply these, we would end up with A equals to 13, which makes sense because 13 over 13 would reduce to 1 over 1. All right. So that wasn't too bad. All right, so hopefully you're getting these right so far if you tried this before. Now the last three are the little bit more challenging ones. These, if you notice, the sides are given, but an angle's not. So common mistake is we think this is a number 0. This is not a 0. It's a little bit hard to see in the picture, but this angle, this is actually it looks like a O, but it has a belt around it. And so this is the Greek letter called theta. All right. So it's a letter that we use to represent usually angle measurements. All right. So it's the same thing as using like the letter X or Y or Z or K, J, any letter. This is just a Greek letter. And so what we want to do is find the missing angle. So really what I'm going to do is I'm going to do the same thing I did on the previous problems, which is set up a proportion, because that's really just what helps us picture what's going on here. So what I do know is the slope of this triangle is 4 over 4. All right, so the first thing I would do is say, okay, well, I know this is 4 over 4. And then, well, I don't know what the angle is, but if I want to know the angle, before I was looking up the angle and figuring out the slope ratio, but now really I need to go backwards. If I could figure out what this is, this ratio, then maybe I could figure out the angle measurement. Well, 4 over 4 reduces to 1 over 1. So what is the angle? What is the slope angle that has a slope ratio of 1 over 1? So if you remember, we actually just saw this in part C, which is slope ratio of 1 over 1 had an angle of 45 degrees. So if I was writing an answer to this one, I would say there really isn't a lot of work here. It's really just you looking it up. And I would say theta is equal to 45 degrees. And that's it. So really the work that you needed to show is just you reducing the fraction. And then the rest of it is you looking it up in your notes. So let's try the same thing on part E. So I'm going to set up my proportion. So this is going to be, so I have 20 over 50. And again, we're trying to figure out this theta. So that means we don't know what it is. So then I need to reduce this fraction to see what that comes out to. And so this is going to reduce to 2 over 5. And so then at this point, I would look up in my notes to say theta is equal to, and I believe this one was theta 2 over 5. So I'm just going to scroll up. So 2 over 5, which one was 2 over 5? All right, so here it is, 2 over 5, 22 degrees. So I'm going to write 22 degrees. All right, and that's it. All right, so that's that one. And the last one is, let's see, let me zoom in. All right, so if I set up a proportion here, same process. I'm going to look at the angle, 79 degrees, and I don't remember this one. So if I look back for 79 degrees, 45, 18, 22, 11, I I don't have an angle of 79 degrees. So what is it? What do we do? 79 degrees. Well, what I do know is if I want to set up the other part, rise and run would be what, y over 7. But this other part is questionable, right? We don't necessarily know what is this ratio. So we don't have a 79. So either this means we need to figure it out, or maybe we do have enough information. All right, so at this point, let's look back at something we already know from the information we have. So this actually ties into the next problem. And so this is problem 80, where if I think about it and I look at the other angles, other triangles that we had, starting with the 11 degrees, if you notice, we didn't really talk about the other angle in the triangle. So something we know about triangles is all the angles in a triangle should add up to 180 degrees. Which means if I know this is 90 degrees and I know this is 11 degrees, then I could figure out the missing angle. And if we do that, you notice it's 79 degrees. Okay, so this should be something, this is something we know how to solve. Let me move this up. So if this was the problem, if we just knew it was 11 degrees, then we could solve this by setting up a proportion like we normally do. And 11 degrees is 1 over 5 as a slope ratio. And this one would be 7 over b. And that's something we could solve. So b would be equal to 35. So that's something we're familiar with. And so if we're given a problem like this one on the right side, you'll notice it's the same triangle. It's the same triangle. The only thing that's happened is it's been rotated and reflected. They turned it in a way so that now instead of the 11 degrees being down at the bottom, now it's at the top. So that means the 79 is now where we normally look for the angle. And so you'll notice they didn't just move the angles, but look, 11 degrees across from 11 is 7. Across from 11 is still the 7. Same thing, across from 79 is the side we don't know, and across from 79 is the side we don't know. So these are the same triangle. So how can we use our information from the first one to answer the second one? So if I set up a proportion, let me move this over a little bit. So if I set up a proportion for this one, and this is basically the problem from problem 70, F, that we weren't able to do. Well, if we think about it, this is going to be y over 7. What's this fraction going to be? All right, so we can't just use 1 over 5 because that's 11 degrees. So when I look at these two fractions, I notice they look almost the same, except this one has the 7 on top and this one has the 7 on the bottom. So what we've done here is we've pretty much just flipped these fractions upside down. So if I flip one of these, maybe if I flip the second fraction, that'll work. So I'm gonna write, instead of 1 over 5, let's write 5 over 1. So then that would mean that 79 degrees has a ratio of 5 over 1. So let's see if we get the same answer. So if we cross multiply on these, what does it give us? So this is going to be 1 times y is y, and 5 times 7 is 35. So we still found the missing side to be 35 on both of them. All right. So only thing we did was we flipped this fraction. So that means we're learning more angles and ratios. All right. So question is, how are 11 degrees and 79 degrees related? Well, 11 and 79. What happens when we add 11 and 79? So 79 plus 11 is 90. So these two angles add up to 90 degrees. There's a name for that relationship. Do you remember the name of that relationship? So how are they related? They are complementary angles. All right? Angles that add up to 90 degrees are called complementary angles. How are the slope ratios related? How were the 1/5 and the 5/1 related? What do we call that when we flip a fraction upside down? All right, they are reciprocals. All right. All right, so we're going to use that information to say, well, if that's the case, well, what about other angles that we know? So here's an example of a triangle 68 degrees. Well, 68 degrees was not on our list. So then maybe if I think about what the other angle is, that might help. So what is the missing angle? So I know these are complementary. These two angles are complementary, so they should add up to 90. So what is, so I'll call this theta. So that means theta plus 68 should equal to 90 degrees, which means I believe if we subtract 68 from both sides, then theta is equal to 22 degrees. Now 22 degrees is something we should be familiar with. We've seen 22 degrees. So what I remember about 22 degrees is the ratio was 2/5. So this is 22 degrees. So if I set up a proportion for this triangle, that means if I'm going to use rise over run for 68 degrees, which is going to be 30/x for this specific triangle, then what's this going to be? What's the 68 degree? Well, if 22 gave us a fraction of 2/5, then 68 degrees is going to be 5/2, right? Remember, reciprocal. We talked about that on the previous problem. So let me write that separate. So if the angle is 68 degrees, then that's going to give us 5/2. All right, so then that means we have a way of solving this. So this would be, I'll solve this. This is 5x equals to 60, which means x is equal to 12. All right, so I kind of showed you up top like some extra work, I wouldn't expect this in a problem. You would just look at it and say, oh, hopefully you could do that in your head. And that's 22, and you're like, oh, 22, I remember, that's 2/5. And then you could simplify it from there. All right, so what we're trying to get to here is if one angle of a right triangle has a slope of a/b, then the complementary angle has a slope ratio of b/a, right? Which is that's what we talked about, the reciprocal. All right, so what we want to do is kind of gather more information. All right, so the next part, it's actually a resource page. Usually you hand this out, and so I will You will have some time to copy this down in a couple of lessons. But what we've done is we're trying to organize all the information we have. So what I've done is I've highlighted the ones that we do know. And the 11 degrees is one we talked about. 18 degrees. These are all the angles that we talked about. 22, 45. These are all the ones we know. And slope triangle. These are the slope triangles that we've seen. Right? These are just redrawn pictures of what we've seen. And on the right column is the slope ratio. So we have the slope angle and we have the slope ratio. This is all the same information that we had before. We're just organizing it into one sheet so that way you could have it in one place. So you'll notice there's some measurements we don't know yet, but what I want you to try to do is see if you could complete some of this. I've highlighted the ones that you should be able to figure out. All right, so this list goes, I'll show you kind of all of it. This is as much as you're gonna kind of have in your notes. And I'll give you all the solutions to this in maybe the next video, possibly. But definitely see if you could try to complete the ones I've highlighted. So you'll notice I've added the 79 degrees. Remember, 79 and 11 were connected because they're complementary, 90 degrees. So 18 and 72 add up to 90, and 22 and 68 add up to 90. So see if you could complete these. I've done this one for us. I suggest writing all these down, but try to do these on your own and see if you can figure out what those are. And we will talk about the whole sheet in the next lesson. So I'll leave those on the screen for you. And so see if you could try to do those. Alrighty, that's it.